Welcome back to the Engineering Lab. Today, we are cracking the code on a major Cambridge mathematics obstacle. We're specifically targeting syllabus code 0580. Now, I want you to picture this. You're sitting in the exam hall. The timer's ticking down. You turn the page, and there it is. A question loaded with numbers so absolutely massive or so incredibly microscopic that just counting the zeros makes your eyes blur. This is exactly where we see two classic types of students crash and burn. First, you've got Alex. Alex overloads with raw mathematics facts but has no strategy. Alex tries to brute force the calculation, writing out line after line of endless zeros, wasting precious time. Then there's Sam. Sam rushes. Sam sees the command word, panics, misses the actual requirements, drops a decimal point, and boom, entire marks are lost. Today, we are going to fix that. We are mastering standard form. This is your ultimate mathematical superpower for simplifying extreme numbers and building a completely bulletproof exam strategy. By the end of this session, you'll be converting these intimidating numbers into clean, manageable chunks with absolute quality control.
Let's look at our strategic roadmap for today's session. We've got 6 key areas to conquer. Section 1, what is standard form? Section 2, tackling large numbers. Section 3, mastering small numbers. Section 4, multiplying and dividing. Section 5, adding and subtracting. And finally, Section 6, core standard form rules. We are taking this step by step so your foundation is rock solid. All right, let's jump straight into Section 1. What exactly is standard form? Think of it as the elegant solution for extreme numbers. Let's look at the core challenge here. The world population back in 2015 was approximately 7.2 billion. Written out as an ordinary number that is a 7, a 2, and then 0,000,000,000. That is 8 zeros. Now I want you to imagine the absolute headache of repeatedly writing out that massive number in a complex Cambridge past paper equation. This is exactly where our student Alex goes wrong. Alex tries to multiply or divide this raw number, but when you're under exam pressure and the clock is ticking, the chances of dropping a 0 or accidentally adding an extra 1 are incredibly high. It is incredibly tedious, it takes up way too much space on your exam paper, and it's a magnet for those silly, avoidable mistakes. We need a secure, stress-tested shorthand.
And that shorthand is standard form. The format always looks exactly like this. It is a number, which we'll call a, multiplied by 10 to the power of n. But here is the secret sauce, the absolute golden rule that examiners are looking for. Pay close attention to this condition right here. A must be a number between 1 and 10. It can be exactly 1, but it must be strictly less than 10. You cannot have 0.5, and you absolutely cannot have 12. It has to sit right there between 1 and 10. The n is just an integer, a whole number, and it can be positive or negative.
Before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, tackling large numbers. This is where we learn how to cleanly convert those giants into standard form. The sheer beauty of standard form is that you don't even need a calculator for the basic conversion. You just need to follow our mathematics success blueprint. It's a foolproof 3-step method. Step 1, take your massive ordinary number and physically move the decimal point until you create a number that sits cleanly between 1 and 10. Step 2, carefully count the exact number of places you had to move that decimal point. Step 3, that count simply becomes your positive power of 10. You can actually write down the final answer without showing any messy intermediate steps just by visualizing this decimal jump. Let's actually see this in action to lock it in. Check out example 8.1 from our source material. We are starting with 6,300,000. Now ask yourself, where's the decimal right now? It's hiding quietly at the very end, right after that last 0. To satisfy our golden rule and get a number between 1 and 10, we have to drag that decimal all the way across the number, placing it squarely between the 6 and the 3. That gives us 6.3. Now how many spots did we move it? Count them with me. 1, 2, 3, 4, 5, 6 places to the left. Therefore, our power of 10 is a positive 6. The final, incredibly elegant standard form is 6.3 times 10 to the power of 6. Look at how much cleaner and safer that is to work with. This is how top students secure their marks. All right, Section 3, mastering small numbers. We've handled the giants. Now let's manage the microscopic. The steps for these tiny decimal numbers are almost identical to what we just did, but with one critical, massive difference. Step 1 remains exactly the same. Move the decimal point until the resulting number sits between 1 and 10. Step 2, count the number of places moved. But here is step 3, and this is where our rushing student Sam always loses marks. You must put a minus sign in front of that power. Let me repeat that because it's vital. Large numbers get positive powers, tiny decimal numbers get negative powers. Do not forget that minus sign. Let's look at example 8.2 to really cement this. We are given the number 0.000003. Writing all those leading zeros in an exam is practically begging for a transcription error. So let's grab that decimal point and move it to the right until we hit a number between 1 and 10. We sweep it past all 5 zeros and land right after the 3. That gives us a clean 3 as our base number. We moved it exactly 6 places. But because we started with a microscopic decimal, our power has to be a minus 6. The flawless final standard form is 3 times 10 to the minus 6. Extremely precise, no room for error. Let's do a rapid-fire data scan challenge right now to really test your reflexes. Look at these ordinary numbers. 7,000 becomes 7 times 10 cubed. That's 3 decimal moves left. 84,000 becomes 8.4 times 10 to the 4th. Now drop down to the small numbers. 0.003 becomes 3 times 10 to the minus 3, and 0.000082. We move the decimal right past those zeros and park it between the 8 and the 2. That is exactly 5 moves, so it becomes 8.4 times 10 to the minus 5. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's keep this momentum going. Section 4, multiplying and dividing. This is where we level up and start using the laws of indices. Before we do the actual math here, I need to give you a serious strategic warning. Multiplying and dividing in standard form require a completely different methodology than adding and subtracting. This is a massive trap in Cambridge exams. It is absolutely crucial to clearly compartmentalize these two sets of rules in your mind. If you don't, you will suffer from cognitive overload when facing a mixed problem set, and you'll end up mixing the techniques. Today, we are making sure you have two very distinct, isolated strategies. For multiplication and division, the strategy is brilliantly straightforward. You combine the base numbers together, and you combine the powers of 10 together, completely separately. You are essentially taking one intimidating problem and splitting it into two very easy problems. Because you are multiplying powers with the exact same base, which is base 10, you just rely on your standard laws of indices. As a quick refresher, when multiplying, you add the powers. When dividing, you subtract the powers. It's that simple.
Now, let's put this to the ultimate test with example 8.3. This is a classic find the flaw scenario. We need to calculate 7 times 10 cubed multiplied by 4 times 10 to the 4th. Following our strict rule, we isolate the base numbers first. 7 times 4 gives us 28. Excellent. Then we isolate the powers, 10 cubed times 10 to the 4th. Using the laws of indices, 3 plus 4 is 7, giving us 10 to the 7th. We put them back together and get 28 times 10 to the 7th. Now this is exactly where a student like Sam stops, writes the answer down, and loses the final mark. Why? Remember our absolute golden rule. The number at the front must be strictly between 1 and 10. 28 is way too big. So we have to perform a quality control adjustment. We convert that 28 into a 2.8. By doing that, we've effectively divided the base number by 10. To keep the whole equation balanced, we must instantly multiply the power side by 10, raising it from 10 to the 7th up to 10 to the 8th. The true, fully correct final answer is 2.8 times 10 to the 8th. Never ever forget that final adjustment step.
Fantastic work so far. Let's pivot to section 5, adding and subtracting. We are changing gears and playing it completely safe with ordinary numbers. Here is a specific stress-tested piece of advice straight from the source material. When you are asked to add or subtract numbers in standard form without a calculator, it is infinitely safer to change each of them back into an ordinary number first. Let's look at example 8.4. We have 7 times 10 cubed plus 1.4 times 10 to the 4th. Do not try to force a calculation with mismatched powers. It's a recipe for disaster. Instead, we strategically revert them. 7 times 10 cubed expands back out to 7,000. 1.4 times 10 to the 4th expands out to 14,000. Now, look at how simple this is. Just add them like normal. 7,000 plus 14,000 equals 21,000. Finally, you just convert that 21,000 back into standard form, placing the decimal after the 2 and counting 4 jumps, which gives us our final answer of 2.1 times 10 to the 4th. Yes, it feels like an extra step, but it is undeniably the safest, most bulletproof method to secure your marks.
We have reached Section 6, Core Standard Form Rules. This is your ultimate cheat sheet for the exam. Let's recap the entire system into unbreakable rules that absolutely guarantee top marks. First, the format is always A times 10 to the power of n, and A absolutely, non-negotiably must be between 1 and 10. Second, for lightning-fast conversions, simply move the decimal point, count your jumps, and make that your power. Positive for the giants, negative for the microscopic ones. Third, when multiplying or dividing, completely separate the base numbers from the powers of 10. Do the math, and then recombine, making sure to adjust if your base falls outside the 1 to 10 range. And lastly, for adding and subtracting, prioritize safety. Revert them to ordinary numbers, do the simple addition, and convert back. Stick to this framework, and you won't even need to touch a calculator. So let's circle back to that massive exam headache we started with at the very beginning of the session, the 2015 world population of 7,200,000,000. With our new mathematical toolkit, we take that decimal from the absolute end, move it exactly 9 places to the left so it lands cleanly between the 7 and the 2. The result? 7.2 times 10 to the 9th. No more counting endless trailing zeros. It is precise, it is elegant, and it's an incredibly efficient way to secure your grade. Standard form isn't just a textbook exercise. It's the language of astronomy, quantum physics, and high-level economics. It is how we actually understand the extreme edges of the universe without getting buried in zeros. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @ACEXams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @ACEXams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.